So first of all, happy Halloween and welcome everyone to our Unlocking Your Data Potential today, where we have three great speakers here today to talk about creating data portfolios and preparing for data workshop or interviews. I just want to begin with a few announcements. First of all, it's a fairly informal event today, but we've asked our three speakers to speak first, so please hold your questions till the end, but we will give time for questions, and think of those questions because we definitely want to field them. They all will add sort of different aspects of their data careers to our agenda today. I want to also promote another event. We have Stephen Morris with us, who I'll interview in a few minutes, and he tomorrow is scheduled from 9:30 to 10:30 to talk more about data, preparing for data interviews, and we've moved that event to Arazu, and we are purchasing coffee or drinks for anyone who decides to come and hang out and talk about interviewing related to data with Stephen. Again, that's 9:30 tomorrow morning at Arazu till 10:30. For today's creating a data panel, a portfolio panel, we, as I mentioned, have asked our presenters to speak for 10 to 15 minutes. I'm going to take a few minutes to introduce our speakers. Lee Rainey, who's currently the director of Elon's Imagining the Digital Future Center. Lee served as the director of Internet and Technology Research at the Pew Research Center, and managing editor at U.S. News and World Report. He has Elon alumni who's a daughter, is that correct? What year did she? 2003, and so we have the awesome benefit that Lee has stuck around and shared his experience with us here at Elon. Next, we're going to hear from Ellie Najowitz. Okay, thank you. Sorry, I'm really bad at pronouncing names, but she's a senior technical staff member and lead data engineer at IBM. I met Ellie at another panel that she was serving on here at Elon for Women in STEM, so we're really lucky that Ellie has chosen to help us here at Elon. And just fun fact, just sitting at the table with Ellie, I found at the last panel, I found out that she and I share the same undergraduate alma mater at Allegheny College. And then Ellie went on to do great things, earning her master's degree at Carnegie Mellon University. Finally, I'm pleased to announce Stephen Morris, who graduated from Elon in 2011 with a degree in political science and public administration. So you see they all have different sort of fields behind them, but all bring data to the table. In 2017, Stephen did a master's degree in data science at the University of Virginia. He has been a member of the strategic business development team at Amazon Web Services for nearly 5 years, working with customers in the federal financial sector. In his current role, Stephen often leverages federal spending data to identify opportunities where the government could use cloud computing to help modernize their existing technology infrastructure. Stephen lives in Alexandria, Virginia with his wife and his 2-year-old son. His wife's also an Elon alum, was one of my Periclean scholars. And so we're really happy to have all three of our guests today. So as I mentioned, we're going to start with Lee, and they're all going to sort of tell you a little bit different. Hold on to those questions.
I'm assuming that there's a pretty good distribution of folks here who have varying interests in data. Some of you are living with it, know it, are fluent in it, and are maybe not going to learn a lot from me, but there are a whole lot of folks here who might just wonder where it applies in my life. And so one of my big takeaways, I hope I convince you of, is that don't be turned off by the word data, which seems like a complicated and challenging word. Don't be turned off by the word analytics. And I would invite you to think that every time any one of us uses the word data, you can substitute me and my world for that thought, because what data measures is what we are doing and how we're doing it and the lives that we are leading. So it's a lens on reality. It is it helps us tell a lot about our humans and our behaviors. So I think Ellie's going to get into a lot of that. But a lot of us are living deeply immersed in a data chasm, where a lot of our data are scooped up by social media companies, by analytics firms, by data brokers and things like that. And it's revealing about who we are and what we do and why we think the way that we think. So it's really interesting human stuff. It's not dry. It's anchored in really, really interesting insights into the world. And where I come from, it's good storytelling. I mean, data doesn't work if you can't tell a good story off it, as well as sort of get insights off it. Data underpins trust and truth. So in a world where those are precious commodities, data helps you figure out what the grounding facts are and how to talk to each other about how we get along and understand things. It's the foundation of science. So anybody here who's a science person understands that evidence is the calling card for all of science. If you don't have evidence and your evidence isn't tested by other scientists and you can't sort of prove your point with data, you're sort of drummed out of the field because you're not playing by the rules of so many elements of our society. It enables analytics and it helps you make better, smarter decisions. The argument has been made that starting as data got digitized and got so much easier to manipulate and so much easier to apply software to, so you don't have to do sort of the hard math of figuring it out. The argument was that for the 21st century, data is sort of oil, the fuel of the modern economy, modern relationships and things like that. So this is, I won't read this to you, but this is my poetry about data. It is the sort of most noble thing that you can think of. People who care about data, are curious about it and apply it to their lives, are people who want to fix the world, want to make it a better place, want to make it a place that people understand and, again, sort of grounded in trust and truth. It's also chief economist for Google became famous at the turn of the 21st century by saying that data science is going to be the sexiest job of the future. And it's turned out that way. People who are fluent in data and can work with it, first of all, have great careers and great prospects, and they live in a world a little bit more knowingly and a little bit more comfortably compared with people who don't know a lot about data. It's also so important because we are now sort of data generators, and you can't live in the modern world without understanding that almost everything that you do, certainly with your devices, your digital devices, and much of the stuff that you're not even thinking about, all your credit card purchases, your location data and things like that are being captured by these firms, and they're big businesses called data brokers who are assembling incredible profiles of you. And so understanding where that is, just to protect your own privacy and your own autonomy, is part of the challenge for living a modern life. So there's not only a noble, poetic side of understanding data, there's also a way that if you don't understand it, you're not going to have nearly as much capacity to run your own life, to have as much agency as people who understand how to protect themselves, how to work with data, as opposed to people who are sort of manipulated by the data brokers. Just to show you how all the fun things that you can do with data, I'm going to harken back to a bunch of the stuff that I was doing at the Pew Research Center before I came here, although I live in data here. But just sort of, here's what data can tell you. These are data that we collected at the Pew Research Center about the rise of all kinds of digital activities in the world. First, there was the rise of, well, look, there was 1% of American adults had home broadband in the year 2000, so at the turn of the 21st century. So a world that you live in now would be mystifying to somebody who was asleep from the year 1999 to now. So this is an incredible story that has unfolded in your lifetimes, but is very different just a generation and a half ago. About 90% of Americans have smartphones. Nobody had a smartphone until the mid-2000s. So again, all the shedding of data. There's social media data. We didn't measure every possible social media company, but YouTube's gigantic. TikTok grew spectacularly from 1921 to 23. Facebook is pretty high, even though Facebook isn't the most popular thing with people of a certain age. There are just interesting ways now that this array of social media that we're using is one of the reasons that it works for us, and if you like it, is because it's getting information about us and feeding our interests and giving us access to people and networks and that are things like that. It's all undergirded by this amazing story about transistors and about computer chips. This is an algorithmic scale. This is not sort of 1, 2, 3, 4, 5, 6. This is 1, 10, 100, 1,000, 10,000. On an algorithmic scale, we now have more computing power in our phones than was available to the space program in the 1960s. And so it's enabling a ton of stuff to happen in the world. That's data. It's just showing you how modern life is enabled by incredible advances in these things, and that's just a fun way to demonstrate it in chart. Here's another big data story that talks about life in our society. And one of the amazing things that has happened in the past 150 years is we doubled the life expectancy of most people. Never happened in human history before you started to get modern medicine and things like that. But again, the data has told that story. And one of the most important things to know is that in this period, there has been a sort of a fall off in life expectancy. And for certain people, particularly white men, there are now things that are called deaths of despair that are measured by data. You know, every time somebody dies, somebody logs that into a database at the population centers of the U.S. government, or the CDC, the Centers for Medicine and stuff like that. So we're understanding what's happening in our society by having data available to us and recognizing that the rise of suicide, alcohol-related things, and particularly the rise of drug use by middle-aged white guys in particular is causing them to die, in part because they're not as happy with their lives as white middle-aged guys were half a century ago. Here's a sort of STEM-related stories about, there's been large concerns about the gender disparities in STEM jobs. We've measured data in a variety of ways. Women are more likely than men to be in health-related jobs. Men are much more likely to be in computer and engineering-related jobs and stuff like that. But there are ways, again, this is data telling a story about a big phenomenon in society that you guys are living day to day. Here's a really interesting story about the pay disparity between men and women. Again, data telling a really interesting, subtle story in this map, because for the first time in a variety of cities, particularly bigger urban areas, young women are beginning to earn as much or more than young men. We've never seen that phenomenon in our culture before, and it's just happening in certain spots, but it's a harbinger of things to come, and one of the things that data can do for you is sort of help you predict the future and see what the trends are. This is a more distressing story that's sort of, again, a data story that talks about big, important phenomenon in society where the wealth gap between white families and black families is 7 times what it will. Black families or white families have 7 times the wealth of black families and 5 times the wealth of Hispanic families. It's only through data that we know this story, and only through data that you can even think about making policies that might change that or might ameliorate that or might sort of begin to think through what some changes would be. Here's a story of immigration. In 1920, I'm sorry the slide is so small, but this is a map showing where the majority immigrant population of a particular state came from. So in Illinois, it was Germany. In South Carolina, it was Russia. In Florida, it was people from the Bahamas. Now in 2022, it's Honduras in Louisiana, El Salvador in parts of New York and Connecticut, Dominican Republic in New York too, and things like that. So again, it's data telling a story that couldn't be a more pressing political issue now in this campaign, but it's a data story that easily translates into lots of sort of emotional stuff that's going on in the culture. Here's the global warming story. Again, another story about the relationship between carbon emissions and land temperatures around the world. And one of the fun things you can do with data, did people know a thing called Ngram, the Google Ngram, where they N, the letter N, G-R-A-M. It's fun to play with if you want. But Google has digitized every book it could get its hands on from the 1500s. This is data from 1800 to the year 2000 about the mention of these particular subjects. And you can build graphs off it on these particular subjects. So between 1800 and 2000, the references in books to sex has gone up way higher, and the marriage number hasn't budged much. The divorce number has gone up a little bit, but it's a fun way to look at big changes in the culture when you're doing this. Robert Putnam, the great political scientist, noted that starting in the year 2000, the references to, this is still a book reference, the references to the word I far surpassed in books the references to Jesus. So if you're trying to think about why we're an individualistic culture or gathering evidence to show how we're an individualistic culture, it's just mentions in books give you a pretty good indication of how that sort of spiked in the 21st century. Here's mentions in books of Christ and Jesus, and the grander story here, starting about 10 years ago, hardly any books now refer to either, compared with other references and things. But over time, Christ got more references than Jesus. Really fascinating thing to play with. And just to sort of end you here, there's another tool called Google Trends that you can go to that looks at search history. So it's not book references, but what people are searching for on the web. And you can put in a word. And I compared Elon with Elon Musk, and I didn't even want to show you that slide. But here's the big story since 2004, when we started math and search history. References to data science and data analytics has gone up. So again, it's sort of an interesting indicator of how the field has changed. So that's all I got for you. And I hope you have a sense. First of all, it's fun to do this. I'm pretty energized about it. It's not so daunting. It's just not. You're asking really interesting, you're inquiring of data, what's going on in this world, or what's going on for me? And, there's no subject that's more interesting and important to you than you and the world around you. So I would invite you to not be scared of the idea of working with data and doing the analytics and stuff. It's a very human thing. You're asking interesting questions, and you're trying to figure out how to tell interesting stories off it, and there's nothing more human than that.
You. Are you going to applaud? There you go. All right. Thank you. That was a great introduction. So hi, everyone. My name is Ellie. I'm just going to be talking to you all mostly just about some industry trends. So to just, as a reminder, I work at IBM. I work in the CIO. So specifically, I'm the lead data engineer for our IT data platform. So what does that mean? IBM's a big company. We have over 200,000 employees. There's a lot of data that it takes to run the company. All of the devices, all the network traffic. You can imagine how many cloud containers we have. All of the security vulnerabilities that we have to track. All that has to go in a platform where we can apply analytics, AI, and automation. So that's what I'm responsible for building, along with about 20 other developers. So it's been great to lead that team, and I've always been able to have a career in data. The way I became a data engineer was becoming a very grumpy data scientist, because in the industry, and all we know that, data does provide these insights, but a lot of times in reality that data does not exist, or it is not widely available for you just to pull onto your local and write a script real quickly to generate the graphs, and then you get to make your point. Usually, and about 80 to 90% of the time spent on analytics and AI projects is spent in the data cleaning phase. So what makes a good data scientist or a good analyst better than someone else? It's someone who can actually demonstrate that they can do that data discovery piece better. If I work with a data scientist and they're like, I don't write SQL, if you don't hand me the data in the most perfect format, I'm not going to be able to do anything for you. It's not the most valuable data scientist. So when you all are working on your data portfolios and you're thinking about this, I urge you to grow your skills in those areas around data discovery, how to move data around, how to work with different kinds of data, and how to work with large amounts of data, because it just seems to be getting bigger. And it's becoming a problem for companies. Of course, storage is cheap, but we all do get the bill. And at the end of the day, if you're not doing something with your data, what is the point of storing it? What's the point of making sure that it's secure and encrypted and replicated for resiliency? It's still a huge investment to maintain data, but it can provide an immense amount of value. So I'll be going through maybe a few different kinds of data that I would encourage you all to work with, and probably the first one that you've worked with is table-based data. Excel, a very traditional, like a Microsoft SQL database, that was probably your first introduction to data, was looking at data in a table. And this is what federal and public data can look like a lot. This is what my first job was actually at Wells Fargo. That's all banks ran on. It was like Oracle and DB2 databases for the most part. So all relational data, it's normalized if you've ever taken a data modeling course. So you should know how to work with that. And I'm sure most of you do. And that's always, again, a great place to start. Now, I would say a lot of the data that we're starting to work with more, especially for AI, is starting to go more into what we call unstructured data. So it means it doesn't fit in a table. It's literally unstructured. There isn't a lot of control around it. And, kind of informally, I'd say, it's not very pretty. If you were to just look at it with your human eyes, it's harder to navigate. So kind of the first step of this would be probably like a document database, or like MongoDB that would hold JSONs, or Parquet files or Avro files. Those are your unstructured data files, basically. And that is a great thing to demonstrate because you'll see that a lot in manufacturing. You'll see it in IoT. Internet of Things. So think about it, you're working in a manufacturing center. There's dozens of sensors that get set off and that are sending a ping every 5 seconds. You're going to generate a lot of little logs. Those come in as small JSON objects, and they all get thrown into a NoSQL database. So that's just an example, whereas like if you denorm that into a relational database, that would be silly. So that's really where a lot of this, NoSQL has come from. So demonstrating that you can work with that data is, definitely a skill set, because, the SQL is a little bit different, how you query it, how you work with it. So as you're interviewing or preparing, think about the kind of data that company probably has, because it might not be relational data. So it could be stored in kind of a normalized or unnormalized form. And, if you're looking into AI, we're talking about text data, kind of like the book with the words. So when you're scanning that much text, you're probably now talking about, you're going to be working with very large objects, and that's where you really get into like object databases. So understanding how to query text, that's really where you start to get into Gen AI. So that's really where we also see our vector databases. So demonstrating that you have the ability to work with text data, especially like that's what the text from an entire book, and that you're able to work with it, organize it, even if it's something simple, because that is the kind of data that a lot of companies are looking to do things with. Because for many, many years, beyond like a basic sentiment analysis, which I guess is good, there's not much we could really do besides find keywords and sentiment analysis, kind of detect if it's happy or sad, and no one's going to triple their profits with those insights. So what people want to do with their text data is build their own, probably Gen AI, so that it can summarize documents faster. Imagine if you joined a company and they could just tell you exactly what you need to do through a chatbot experience. Like, that's what people are looking to do with text data. And then the next thing that falls into that's the last category, is then getting into media, your images, your videos, your sound. There's an immense amount of data out there in the world, and they're very, very rich in the amount of information that we can get out of videos, out of images, and that's something that all companies are working with more and more. So we're starting to accumulate, again, all this data. It's very expensive to store. If you can demonstrate that you can find benefits or optimizations or working with that data, that would be very valuable. So just some food for thought with different data types, and I'll leave you with one other thing that's good to demonstrate, which is understanding data security. You know, in working with data, you will probably have it in a database that's already encrypted. So we're really looking for people who understand, you know, just data security principles, understand maybe how data should be masked or anonymized, identifying personal information. It could be that simple, but certainly securing data is like an entire industry. So you're probably not going to be able to demonstrate something like that on your like local device. But again, demonstrating that you understand the principles and kind of the patterns that you would need to implement to maybe put something at scale, that would be great. And you know, I think there are, you know, just because you're not going to be a cybersecurity expert, security really is expected now with any technical job. So it's always worth it. There's a security course here, just take it. And I think that's all I have.
This doesn't work. What Kristen was talking about earlier, mine's going to be a little bit different because I was going to do another one of these tomorrow morning about prepping for interviews, things like that, and how a data portfolio could be a tool. If it doesn't work, I can just look at my slides and I can convey that to you. So if you... Yeah, that is me. What do I do? Okay. So now that's working, we'll just get into it. So quick intro. I know Chris already kind of went over it. I graduated here in 2011. I was a poli-sci in public administration major. I thought I wanted to go to law school. Well, you guys are probably pretty young, but 2011 was not the best time to go into law. So I moved back to where I was from in Virginia. And I started working for a government contracting market intelligence firm. So I was using a lot of public data to help companies try to find contracts that they could go after and grow their revenue. Next job I went was for a healthcare analytics company, and I hated that job. I was only there for a year, but I learned that I really wanted to get into analytics. So what I decided to do was go to UVA. I did a master's in data science there. I think I was the third cohort. So it's still like a new program. They just built a whole new building. It's pretty cool now. And as the field's kind of blown up, they've had a lot of investment there. So left there, went to work for PwC for a little while in financial analytics. That was a lot of fun working with clients. Consulting is a pretty interesting field if you're into it. And then for the last almost 5 years, I've been at AWS. We call it business development and capture. So I work with our federal customers trying to identify opportunities where they could leverage cloud computing to modernize their infrastructures. Get on your good side, include a picture with a dog and a baby. And that was my wife, who Krista mentioned also was 2011 here. She's walking around exploring all the new buildings. This used to be a big parking lot when I was here, all the way to McMichael. So this is what I was going to cover earlier. We're going to be at Arazu, okay, from 9:30 to 10:30. I've tried to kind of pivot my presentation here a little bit more to focus on resumes, prepped for interviews and how data portfolios can help with that. So if you have questions, come by tomorrow morning and we can talk. And I was also going to do mock interviews tomorrow. If you want to do one of those, or even just like a short dry run, I can do those on Zoom. Probably not like during the day, but we could figure it out. So jumping into it, what's a data portfolio? In my opinion, it's an opportunity to demonstrate your proven analytic skill set. I italicized proven there because everything else is just you saying you know how to do something. The data portfolio can actually show an employer, anyone that you're networking with, what you can actually do. So this could be a GitHub repository. I've seen people build out websites. If you don't have those skills, just start by writing them all down. Very brief, concise descriptions of what you did, what tools you used, why you did what you did. So anything is better than nothing. Why is it important? Don't want to hurt your feelings, but right now you are probably at a disadvantage in the job market because you don't have any experience other than maybe like internships where you've impacted a business's bottom line. And so if all that's on your resume is just experience from classes you take or programming languages you know, it really doesn't come across as well as actually showing somebody and the outcomes. And so right now, a lot of the primary experience for you all is going to be related to like research projects and things like that. So in an interview, you're actually selling your potential to an employer, not selling, what you've done in the past. So you have to highlight all that and convince them of how are they going to be able to capitalize on your skills. So I think a data portfolio is a good tool. Here's some resume examples. I wrote these aren't actual ones, but if I saw this, I would say, okay, this person took a course in analytics in college and they wrote down what they think employers want to see. Here's a better example. This one, I'd say that person took that same course and actually paid attention, took notes, but still without a portfolio to back up the fact that you have all these, you probably just Googled it, looked at your notes, looked at some packages that people use a lot, and put those into a resume. And you probably should have a lot of space on your resume at this point in your careers. So don't worry about taking up a bunch of space. And then also, you could just put those projects into your resume as well. Pick out 2 or 3 and do that. So keys to a good data portfolio, I would say, is have more breadth than depth. Don't just show somebody all the nails that you can hammer in, but instead show them your entire toolbox and your variety of skills so that they can see how it might be applicable to them. Don't just put a GitHub with a bunch of code in it if that's the route you want to go. Unless you're looking to be a developer in a super tech role, they're probably not going to look at it. So use Markdown. Make everything more of a narrative. Why did you do it? What's the outcome? What were the findings? How did it help your team or your internship company? And then also, why did you do what you did? And don't just say, oh, that was what the professor assigned. Make something up to make it a little bit more interesting than just that you did like a homework assignment. This one, you can't always do it, but I like to recommend that you choose things that you're actually passionate about because that comes across a lot more in an interview. If you're excited about it and you have some personal connection to it, it will come across, and that conversation is going to be much more impactful and memorable to the person conducting the interview. Has anyone heard of the STAR methodology? Okay, couple hands up. All right. So for those that haven't, I don't know if Amazon employs it when we do interviews. We're always looking for people to give a STAR response. And so it's an acronym for situation, where the interviewee will describe the situation that they were in, then make it very clear what their task was, what their action was, and this goes back to yours. We hate when people say we. Say I. Tell the person what you did. Don't say my team did this using that. Because then I'll kind of assume there's a pretty good chance that somebody else on the team was probably driving that, maybe more so than you were. But if you can say that here's what I did, here's what I contributed to the team. And then you close with the result. So what impact did your actions have? If they didn't really have anything, but you wrote a bunch of code in R, cool. But if you're trying to convince me that I should be paying you to come work for a company, I need to see what the impact of your work and your skill set actually is. So here's a hypothetical. I think I got time to run through it. We always say, tell me about a time where you had to do X, Y, and Z. So it's never like, are you good at this? It's always, tell me about some historical thing. So without a data portfolio and a resume in front of a hiring manager or something, they might ask a question similar to, tell me what you had for dinner last night. So this could be even just at like a cocktail party and you just met somebody new. In my case, I had to come here today. My wife was at tennis. I just put our son down and I made a frozen pizza from Safeway. Wasn't good, but alternatively, if you were to ask somebody, tell me about the greatest meal you've ever had. So it's kind of similar questions, but the second one allows you to tell a story, situation, task, action, result. So in this case, I could say that when we got married, I was in charge of the honeymoon, band, and I think the buses. So I didn't have a lot to do, but I wanted to make sure I did all of those really well. So we were in Vienna, Austria on our first night of our honeymoon. I had booked this restaurant like 3 months beforehand because I Googled it, and they had this special thing called the kitchen table where you sat like right at a high top and the kitchen was right there. So you could watch these chefs make the meal. It was like 12 courses, wine pairings. They printed off a little menu, wrapped it up and tied it with a bow, gave it to us. We still have that at our house now. So I think of those two, which was like more interesting to listen to. Hopefully the same. That would be bad if it wasn't. But a data portfolio enables you to answer similar questions like that in an interview setting because somebody's not just going to ask you, tell me how proficient you are using R to analyze data. Instead, they're going to say, tell me about this project I see in your portfolio. Why did you choose that particular data set for your analysis? What were your findings? Is it what you expected? If not, is that due to something that maybe you could have done better? Or was it just scientific method? I had a hypothesis, it wasn't right. We moved on. And also, if there are projects you're actually interested in, you can call them, you're smiling, a little bit more bubbly personality, that'll definitely help. Again, they really help to show off your potential. And that goes back to what I was kind of going at. Somebody's not going to hire a new college graduate because they have demonstrated that they can take your profits, grow them 40% year over year. They've done it at 3 companies in the past. They're really going to hire you because they think that you could have the impact moving forward. So it's really about your potential. And if you can tailor these to your audience, do it. Because if you have 3 projects on your resume and you send it to 10 different companies, those 3 projects are not the best for each of those companies, unless you apply to 10 of the exact same industry that you want to get into. So when I applied to Amazon, in the bio on my resume, I said, I'm a curious data scientist. I would never describe myself as that in anything other than a resume. But one of the leadership principles at Amazon is learn and be curious. So if they see curious, and then data science again, it's big time, has been for the last decade or so. Maybe that just gets my resume into that check again pile as opposed to moving on. Kind of goes back to what I was saying, pick the projects that you think are going to resonate the best with who you're talking to. Every resume should have the same projects. And then this one is a big one for me, is a data portfolio is going to have it's going to give you increased exposure with the decision maker. They say that resumes are often reviewed for 6 to 10 seconds. Some say 7.4. I put some asterisks here because if you get the gist in an interview that they've only looked at your resume for 7.4 seconds, I probably wouldn't want to work for that person. So just keep that in mind. But a lot of people, that could be the case. So if you, in an interview, you tell a good story, you have a link to a data portfolio where it's an appendice to your resume, your application, and it was a compelling story, there's a chance they could look back at it after the fact, and then that's more time that they're thinking about you than any other person that that applied for the position or did an interview with. I think that is everything. Hopefully I wrapped up right around the right time.
Thank you to our speakers. We're going to open the floor now for questions. I'm hoping you guys have lots of questions. They gave you a lot to think about. So any questions on the floor?
Hello all, thank you so much for being here. My name is Oliver. I'm a sophomore here at Elon studying data analytics and business. This past summer I had an internship at a manufacturing company where I worked with a lot of Excel stuff, but also some of their internal database stuff and worked on some KPIs in Tableau. All of that data though was under an NDA where I can't just like copy and paste the stuff over to like a data profile or something like that, talking about the security. I've described those projects in detail without giving numbers and things like that in a resume. But how do the intersections of data security and proprietary company information intersect with, I want to put this on my resume or in a portfolio for potential future employers or things like that? How do you navigate that?
Too much. So I mean, you're able to talk about that project. I mean, you literally just cannot like expose the literal data, because if you were to download that, like take it away with you, that would be a problem. But like you just spoke to it now, like I worked for a company and I worked with manufacturing data, and you were able to kind of describe what that data was. I always say it's not good face to kind of diss any company in an interview. So let's say like you found that everything was a mess and like they had problems. You maybe don't want to stress that much, because that might be confidential information. Like, oh, they were, had billions of dollars of leakage. So you want to try and just keep things generalized. And you can kind of speak to things in industry. If you wanted to make a dummy data set, you probably could. But yeah, for someone to validate basically the validity of your project, I wouldn't need to see the physical data. You could just show the results. You can delete the X and Y accesses. Like you can that's what I mean, like kind of scrub it as much as you need to, or kind of recreate basically like something very similar if you wanted to have something to present. But speaking from what you were assigned, what you delivered, and the impact of that, and if you can concisely explain how those three things are related, it's probably what you need. But the internship experience is great.
Super brief talk. Yeah, I mean, I think the way you described it is pretty sufficient. Maybe you're not going to be able to show the GitHub repository, but if you wanted to try to replicate it with something that maybe you're a little more interested in, unless you love manufacturing, more power to you. You could maybe find something on whatever that website is that has tons of data sets. I can't remember. And try to do it. If not, I think the description you gave would be good enough for you.
The one sort of higher level thing, when I was a hiring manager, I wanted to hear the story of the work, and so not having the particulars wasn't ever an issue to me, and I was particularly interested in hearing about problem solving. So finding the right data, running into roadblocks in the midst of the thing, and how you did workarounds to get to it. That's the much more compelling thing that a hiring manager. You want to see a mind at work. And if you can't show the data, that's not really a problem, because you can talk your way through that. I'll be still down to you here.
In the future, do you see like AI becoming more influential in the industry, and like coming from that, are like employers going to want to see you knowing a lot about AI and kind of predicting that future, I guess, in a way, and like getting ready for that?
Survey that was done by Microsoft, and particularly at LinkedIn, and overwhelming number, vastly more than a majority, said that AI is now not only a plus factor, but a qualifying factor. That students who walk in the door without much knowledge about it are not going to get very far, particularly in knowledge generating, knowledge work kinds of places. It's hard to know exactly what that means at the moment, but it's a safe predictor that being passingly at least, familiar and you talk your way through it will stand you in better stead than not.
I think that's all people really talk about at AWS right now, so it's not even in the future, it's like right now. I think there's so many different buckets though, because AI versus generative AI. In most roles, I think Gen AI is helpful from a productivity standpoint, but I don't know if people are really using it to its full potential. Having a skill set in just regular AI, machine learning, knowing classification models, clustering and supervised and unsupervised, having skill sets like that, that's a huge differentiator for any industry. I think, but with all the money that's being poured into Gen AI and the new tools and solutions that are coming out, it's just going to start integrating more and more with everything. So I think having a basic understanding, unless you want to go work for OpenAI and be writing the models, I think just having that baseline would probably be sufficient.
Yeah, I'll just echo. I think it is incredibly important, and there is also nothing wrong with writing the hype cycle of something. When I was graduating, it was blockchain, and I was a blockchain expert. Where is blockchain now? It doesn't matter. But I mean, that's something that you all, as people who are entering the workforce, you could be an expert in something, or more of an expert in something new, because no one knows about it. Like when I applied to my first job, it said that it needed 10 years of Kubernetes experience, and Kubernetes had been around for 3 years. So it was really easy for me to walk in and be like, I know a bunch about Kubernetes, and no one could say they've been working with it for longer. It's only been around for 3 years. So it's great, these kind of cutting edge technologies. You have to kind of be careful, because not every company will use them, probably for security reasons. So don't go too cutting edge, but AI could be a huge advantage. There's so many open source technologies. There are so many free courses. It's definitely something I would encourage you all to take advantage of. I hope traditional AI isn't going anywhere. It makes me feel very old that we're calling it now traditional AI. But generative AI is just if you've ever taken a matrix algebra class, it's not that complicated. The math, I would say. So it's definitely something that's in your all's capacity, but I think we've all said, definitely look into it if you can.
I'm curious about what you guys think about data latency, and whether this is something you think about during your job, and how you deal with it, and how it's a factor in what you do.
I'm going to let you.
Yeah, I mean, I've worked with data latency a lot. It's something, if you work at a global company, or even, you think about it, how long is it going to take for data to get to one place to another, especially lots of data. It's important to understand, but I think it's almost, for me at least, it's been more important to prove and understand from a monitoring perspective how you can even measure if latency is happening, because I have had many people escalate me saying, the program you built doesn't work, there's latency, da-da-da-da-da, and you kind of have to be able to say, prove it. And it turns out, they just weren't connected to the right Wi-Fi. So there's a lot of user error with latency. It's still a very real problem, but would I say, your average user runs into it that much? Not as much. Our networks are getting, better and better by the day. And that's what understanding the physics of how long something takes to go from one place to another. How long should it take to upload a terabyte of data? Because I've had an executive expect that to happen in 0.2 seconds, and I'm okay, I don't know what you've been working with. So understand the realities, but I think at this point our networks have gotten pretty mature that I don't think we had to think about it like we used to. Where, you know, most companies, especially global ones, have a global, you know, IT footprint. At this point, we have caches, so everything flows around the world. You probably wouldn't be asked to like build one of those from scratch, but it is something, of course, always to consider. You have to deal with latency?
So I have a question. You talked about like data security earlier. Why are like social media companies having like so many like issues with like their data getting leaked out to the public, or like other countries like supposedly having access to data? Like what are they doing wrong? Like that maybe other companies are doing right?
That, like, basically, like, your attack surface has, like, I mean, increased like 100 times. And especially with the fact that, you know, we do have things that are on cloud computing. It used to be you have like a mainframe in the office, and everyone could only like connect to that computer. They didn't take their computers home. There was no Slack on your phone. Like, there was no, like, it was a different time. So there's a lot more data. It's much more so available. It's flying around. And you have to make sure that you're securing it at every point. You're securing it at rest, you're securing it at transit, and that everyone has access to only the data they need, which is incredibly hard to do across an entire enterprise. You know, in a perfect world, of course. But I think, you know, security can at times be the first thing to kind of, you know, people forget about it. If, you know, they're needed to cut corners, you know, they'll say they'll go back and do it later. It's called technical debt. And, you know, that's what we call it, at least in my company. When you go back and fix something because you just didn't build it right the first time. So it's just, there's evolving problems. And I mean, I can't speak to social media companies specifically, but I think, you know, they have a lot of data, and it really just, it doesn't take much. It's very, very easy for that data to be compromised. So I think it's just more events happening, and I'm sure you see some of it too.
Yeah, I don't know if I would say social media websites are the main one. I think every company has these issues. I think you hear about social media because social media to function needs as much information about you as possible. So all your behaviors, they have information on it, and then when that leaks, it tends to have a much bigger impact, especially from like day-to-day individuals. Another thing is that you can build things as, you know, zero trust architecture, build them from the ground up with like the best ideas in mind. But most of the time, the weakest link in that entire thing is between the chair and the keyboard. It's a person. So if I can get you to bite on a phishing email, that's typically going to be the easiest way into a network. These days, there's not like in the movies in the old days when they're just like, all right, I'm in. It's typically somebody clicks reset password, types in their password, And then before they can realize what they've done, that person's already changed their password and has access to everything in there. So.
Well, and the biggest security breach in the current moment is the Iranians getting into the Trump and J.D. Vance email accounts. There are just incredibly clever adversaries who are putting incredible resources into going after this. A much more catastrophic leak than a social media leak is the Office of Personnel Management, the White House Executive Office that knows everything about every federal employee, including who we're paying to be spies for us, and who have the security codes on who's manning or the people in charge of national security facilities and stuff like that. All that was leaked, and so the stakes are high, and the incentives to breach the systems are just incredible, and the vulnerabilities are pretty obvious, and you can throw everything at it. There are 200,000 employees at a company. It takes one idiot or one vulnerable person to compromise the whole system. Yeah. Yeah, I mean, so look at the language models. One of the big concerns now about the language models is that they're running out of data to train on. And so there's feeding in synthetic data that is built on the existing system, so it's reinforcing whatever's in the pipeline that exists now, and so it might compromise the models. If they're not getting trained on new, high-quality, fresh data, they run out of juice, or they get worse.
Yeah, I'm gonna stop it, but I'm gonna ask everyone who wants to ask more questions, stick around, socialize, and get information from our wonderful panelists. Let's thank them one more time. And yeah, so there's plenty of food. I can't take that all home, or I might shock my system into diabetes. So please enjoy the company of our guests today. And don't forget that Stephen will be a Razu, and you could have a free coffee drink if you show up and get some wonderful information about interviewing in the data world as well. Finally, I'll say that as the director of Data Nexus, I'm always here to listen to what your needs are. So there was a lot of things that you heard about today. If you feel like you want to know more information, if you need some training in something, Data Nexus is a place where you can just let us know what you need, and we will make it happen. So thanks for coming today, and please stick around with more questions.